Okay, folks, so we are on our downward slide in this class. This is week 5. We are going to start not really covering new material, but we're going to be combining some concepts that we've already discussed. For instance, we are going to be combining um, loops within if-then statements and combining loops within loops, or nested loops as they're called. So just as a review, we have 3 primary control structures in our code, or effectively in any code. We have the sequential control structure, which is one command after another. A selective control structure, which is if one condition is true, then execute these tasks. If else, do something else. And then repetition. So basically, that is our loop that executes one or more commands over and over until instructed to do otherwise. So some of these control structures that we use, we've discussed error handling or defensive programming in past weeks. So we can take a look at how some of that how we can use some of the control structures to do that error handling. So let's take a look at some of the examples. Now, by the way, there are many examples in this chapter, and I highly recommend that you take the time to go through all these examples and review what the code looks like, what the flow charts look like. Now, I will not be going through all the examples. I certainly won't be going through all the flow charts, but I highly recommend that you take a look at all those codes and and then review the what happened segment after that code, and go line by line and make sure that you understand what each line is doing. So let's take a look at some of these examples, and we'll see how these combinations are made. Okay, so this is example 5.1 on page 227 of your text, and this is pretty simple. This is nothing more than an if-then statement contained or combined with a for loop. So if you look at this is the for loop. Now let me change this back. This is in the example. It is count equals 1, and it tests for count less than 11. So now we'll see in just a moment that there's another way of doing this, and it does exactly the same thing. And then once all this code is executed, it increments the value of count by 1. So as it goes through each of these, it executes the code contained within that for loop on each iteration. So on each iteration, it sets the variable total to total plus cost, and then does a test to see if total is greater than the max value that the user set up here at the top. So effectively, what this code is doing is it's going through this for loop 10 times and allowing a user to purchase items 10 times and stay under this max value. And if it doesn't, then it's going to within this for loop, it's going to say if I'm sorry if total is greater than max, then it's going to exit the for. So it'll never get to the end of the if or write out the line saying you have bought so many number of items. It will go directly to the end of the for and print out the last line. So again, on page 229 of the text, it shows exactly how that code is working. So and certainly to greater detail than what I'm giving you right now. So I highly recommend that you take a look at that. So still, let's go back to a couple of these other examples. We'll do 5.2 real quick on page 229. So this is effectively the same thing. You have the for loop that has a certain number of iterations, and in this case, if you notice that in 5.1 it was saying it was testing for count less than 11, which is 10. So in 5.2 it's saying count less than equal to 10. So it's effectively the same thing. So it's entirely up to you. It's the same demand on the resources in terms of processing and memory and all that. It's just a different way to a different way to skin that cat, as I like to say. So again, this is an if-then statement contained within the for loop that will execute on each iteration of that for loop. So again, review that information in the text and review the what happened segment behind that code, and it gives some pretty great detail on how each what happens with each line of that code. So let's take a look at example 5.7 on 238. So one of the objectives of this chapter is to show how complex the we can make our code with the embedding of the control structures within other control structures. So again, we have for loops or a for loop with a case statement contained therein, and it will iterate through that for loop depending on what the value in that variable is, and of course the user will set that value following following this line asking how many number of items they're going to buy. So you can indeed make some pretty elaborate code with these embedded control structures. Okay, so real quick, I want to point out something. If you take a look at page 242 and 243 of your text, this talks about the write statement compared to the print statement. Now, the print statement is more accurate in terms of how actual programming languages behave, because in just about every programming language, it will keep printing information on the same line until the code tells it to create a new line, and we'll see how to do that in in this example and on page 243. So if you look at this, we of course declare variables here and prime the variable count to 0, and then we will write information out to the user. Now in our pseudocode, in the syntax of this code, in the syntax of this text, following each write command, it has an automatic new line, so it automatically goes to the next line. So after it displays enter your name, it automatically goes to the new line, so the cursor is sitting beneath that displayed text waiting for the user to input. And the same with these, it will print out, choose one of the following symbols, and then print out this line, and on each of those it will print out a new line, and the same with these. So in this case, it's going to print the contents of the variable name, which was entered at this location, and then create a new line, and that's what this segment does. And then it will print out the characters, either the asterisk or the pound sign, identified by what the user indicated. So from this point forward, on all of our assignments and discussion, initial entries for the discussion, we're going to be using that print, the print statement with a new line to demonstrate to me that you understand how that works, and what the difference is between the write and the print. So in this code, what's going to happen is that I will, following this line, I will input my name, Tony, and then choose asterisk at this point right here, and then I will choose yes, and it will print asterisk asterisk space. So if I were to choose no at that point, it would just put a line of asterisk. And of course, it would stop when it reached 4 because that is this length of function, which is effectively a program written by someone else that is among the library of functions available in that programming language. It will take the number of characters and put that value in this variable. So once it reaches this variable, while count is less than equal to number, it will keep printing out those characters and then stop when that value is reached. So again, I certainly recommend that you go through the what happened segment on page 244 of the text, and again that it certainly goes into far greater detail than what I'm giving you. I'm just kind of giving you the basics of how that works and the difference between the write and the print statements. So real quick, if you look at page 245, that blue area there displays in C++ what the same code was doing in pseudocode on a couple of pages back. So you'll notice that rather than the new line statement down about midway down the page, it has a cout which displays out to the user the content of the variable name, and then it has an indel, which is basically a new line. And that's how that's done in C++. Of course, all different programming languages have different commands of doing that. That just demonstrates how that's done in C++. So take a look at that again and compare that to the pseudocode a couple of pages back and notice the differences in that. So one other thing I want to point out, and this is not part of your required reading, I don't believe, but section 5.3 talks about it's a random number function, and again, a function is a segment of code that someone else has written that is now contained within the library of that programming language. So you can use that function without having to rewrite all that code again. And it's one cool thing about modular design and about and certainly about object-oriented programming, and that's beyond the scope of this class. But you guys will certainly get more familiar with that as you press on into the higher level languages. So we are we're also talking about nested loops, and in the case of this text, it's going to be nested for loops. So um, in a nested for loop, you have an outer loop and an inner loop, and we'll see that here in just a second. And there are a lot of folks that have a hard time wrapping their brains around how that works. But we'll take a look at that real quick, and I'll show you um, how that works in our pseudocode. So if you take a look at example 5.14 on page 254 through 256, and we'll take a look at the code here in just a sec. Okay, so this is our nested for loop from page 256, example 514. So we declare our two integer values, which are out count and in count. So when we enter the outer loop, out count is set to 1, and of course it's tested to see if it's less than or equal to 4, and then once the guts of that for loop uh, are executed the first time, it will increment out count by 1. So so right now out count is 1, and we enter the outer for loop and and then enter the inner loop. So when we go into the inner for loop, we set in count equal to 1 and test to make sure that it's less than equal to 5. And of course, in count is less than 5. So we will go to this first line and we'll write the word bean one time. So, and then it goes to N4 and it will increment through this 5 times because we start at 1 and we're testing to make sure it is less than equal to 5. So we'll print bean 5 times. So on the fifth iteration, in count is going to equal 6. So it's going to exit the outer for loop and go back to the inner for loop, and it's going to increment out count by 1. So that will equal 2, and then it will enter the second for loop. So I'm sorry, real quick. When it exits the first for loop one time, the first time rather, it goes to this right space, and effectively that is a new line. So we could have done a print new line or print NL in the brackets, or print a space. I'm sorry, write a space with our pseudocode. So again, on the second iteration of our outer loop, we go into this this inner loop. So now previously in count equaled 6, right? So now that we're back into this loop, what is in count going to equal? Well, now that we're going back into the loop, it's going to set the in count back to 1 again. So we're starting with a fresh set of iterations through that for loop. So it's going to count through that those 5 iterations, going to print bean 5 times, and it's going to hit this. It's going to exit that for loop because in count's going to equal 6. It's going to write a new line. It's going to come up here and it's going to increment out count 1 time. So effectively, it's going to do that 4 times. So bean will be printed 4 sets of 5, and then so at that point, out count equals 5, which is not less than equal to 4, so it's going to go to end program. So again, it's very hard for some people to understand how that works. So on each iteration of this nested for loop, the inner loop is a fresh start on that counting variable. So it's very very important that you understand that, and it's going to be very important that you understand that concept and the concept between the print and the write for assignment 3. So again, pay very close attention to how that worked, and read the what happened segment following 5.14, and make sure that you understand that. And if you don't, let me know and we'll get that cleared up. So again, now this chapter really doesn't have any new concepts at all, other than some new functions and things like that. But there are no new concepts. We are basically combining concepts we've already learned. So please read through that chapter very carefully, and read through all of the examples those that I've covered, those that I haven't. And if you have any questions about that, let me know, and we'll cover that in class. All right, thanks a lot, and good luck on assignment 3.